We now discuss case history number 4, a conversion from a producer well to an injector well. Example 4 is from the Buzzard field in the North Sea region. At some point, a dedicated injection well was required to maintain the pressure support for the Buzzard field. And the operator identified 2 wells for water and gas injection. The main goal was water injection, and the gas injection was more of a feasibility study. Those wells did not have any topside metering solutions. For that reason, utilization of the downhole optical flow meters was important. At that point, the operator contacted us and they wanted to know whether the optical flow meters could accommodate a service change from producer to injector, and whether or not the meters could measure the injection rates. The answers to both questions were yes, because the optical flow meter measurement is a bidirectional measurement, and the flow meter will measure the flow with the same accuracy regardless of the direction of the flow. Also, the type of the fluid is not relevant to the flow measurement, because if you remember the discussion we had in an earlier section, the optical flow meter has a universal calibration, and the type of the fluid, whether it is water or gas, does not have any impact on the flow measurement. All the details on this case history can be found in an SPE paper co-authored with the operator. Now, let me present some of the key results. This plot shows the well in the producer mode before it was converted to a water injector. The orange markers represent the oil flow rates, and the blue markers represent the produced water flow rates. And most of the time, the water cut is in the range of 10 to 15%. After the well was converted to an injector, we see that the blue markers now dominate the plot, and the water cut is in the range of 95%. Now, the flow meter still sees small amount of oil production in the range of 5% or so. That is because the injected water is the seawater, and its properties were different from those of the produced water in the producer mode. The correct properties of the seawater were not used in the flow calculations because they were not available at the time. With the use of correct properties of the seawater, the water cut would have been 100%, meaning all water, and the oil production would have been 0. Now, here, the correct injection rate is equal to the total flow rate, which is the sum of the water and oil flow rates. Let me explain why. But first, it is important to note that there was no change made to the optical flow meter, and the meter was running in the two-phase flow calculation mode. So, with the incorrect properties of the injected seawater, the two-phase logic of the optical flow meter was distributing the total flow rate between the oil and water phases. But we know that this is the injector mode, and all that fluid is really water. So once we clarified this point to the operator did not see any need to optimize the flow measurement system, because they understood that the total flow rate, which is the sum of the water and oil flow rates, was equal to the injection rate. It was also possible to optimize the system, especially the speed of sound of the water and also the speed of sound of the oil. It is possible to optimize that as well. And this will be a subject of another case history that we will discuss in a later section. This case history demonstrates that the optical monitoring system can adapt to changing field and well conditions. And it also highlights the system's ease of use for different applications with no or minimal additional effort to accommodate a change, such as this one from producer to injector.